So, but that communication function, that translation function, taking what is kind of a complex esoteric technology, but turning it into, so what's it mean to me is actually part of the job from time to time.
Hey,
hello, Joel.
Steve, how are you doing today?
Doing good. Just getting read in on all the cool stuff you do with audio, and sounds like you got quite the team here. It's a good thing.
Yeah, we do. We have a great team, awesome production crew, and I like your background there on Zoom. That's a really high quality background.
That's right off the point here. I live in Annapolis, Maryland, and that's a picture my wife Edith took after one of the storms that we had here a couple of years back. And I just thought it was so cool. But yeah, it makes a nice background. Because the regular room I'm in, I'm in a stand-up desk setup because I just got tired of sitting, right? And it's a very boring background if I turn off the virtual stuff. So I've got a whole variety of them.
When did you start with the standing?
Oh, you know what? I've actually been using a standing desk probably about 4 years now. It actually started out, so I have, by virtue of a whole bunch of reasons, 3 different compressed discs in my back. And I noticed when I was standing around at trade shows, I was getting just fatigued, and talked to the doc, and he said, hey, well, try these sets of exercises, which I did. He also said, you're sitting a bunch. Why don't you get yourself a stand-up desk? And over a period, it took a little while, but it's over about a year's time, I found, I can stand for hours now without any back pain. So it's actually helped quite a bit with that. You got to, pay attention to some other stuff, your feet, and get a pad under it and that kind of stuff. And, I'm using some Dansko shoes, which are good for, arch support, that sort of stuff. But it's worked out real well for me.
Do you spend a lot of time improving your health and growing and working on yourself?
To some extent, I think everybody has to, right? But just by virtue of the pace at which everything goes, you got to pay attention to that sort of stuff. So you got to watch what you eat. I've had my moments when I wasn't, right? So my weight's gone up, weight's come off. With the whole COVID thing now, it's nice because, I can actually be home and work out. I got a little workout area downstairs. That's been a benefit. I used to do a whole bunch of travel, and the travel's cut back, quite dramatically now. So I can spend some of that travel time doing other things. Although I will tell you, the meetings expand to kind of fill the time available. So, I think everybody's life now is, Zoom, WebEx, GoToMeeting, FaceTime, Teams. There's a whole variety of tools out there that people are using now.
I'm a fan of Zoom. I thought they were like a really great company. I had on Harry, and I was just really impressed with him as like a CIO.
Yeah, I think Zoom of all the tools is probably the most user-friendly. And I think that's one of the reasons, it took off like it did in terms of the number of people using it. You use some of the other ones and it feels fairly antiquated, right? And, they put in place things like the virtual background and all the things that you would kind of think of as being appropriate and kind of a modern interface. I think they did a great job with the tool set. Nice.
And you're in telecommunications background, right?
Yeah. I've liked communications pretty much for forever. And the company I work with, Sienna, right? So that's the company I work for. We are the guys that basically light up the internet, right? We're the ones that light the fibers that interconnect the continents, right? The submarine cables, as well as the big cities, the big metropolitan areas. So we've been driving connectivity and capacity out into the infrastructure for, that's about 25 years.
Wow. I remember I saw a few years ago this documentary and it had the ship and they were going, in the sea somewhere, and they had this like crane thing and it would pick up this giant cable
out the back. Yeah. That's it. Submarine cable.
Yeah, the one I saw, that's what it's called, a submarine, because it's big and it's round and so it's like this fiber of light. And then I saw them doing like a repair on it, and I was just watching these like, it was like a documentary or a show, and I was blown away by this. And at that moment, I realized that, we actually have this web of cables strung around the world, and that's the part of the internet.
It's fascinating. I mean, a lot of people still think, the intercontinental communications is satellites, and it's not. Like 99.9% of it is all under these submarine cables. And the cables themselves aren't that big. Think of like a big, thick garden hose where the repeaters are, which are the optical amplifiers, right, that, allow the signal to propagate that long of a distance. They are, beefier, they're bigger, but the actual cable itself isn't all that big. And you're right, they're what interconnect, all the major continents and carry the vast, vast majority of all the, internet communications and such. And it's one of these things that it just works so well that unless there's been a real problem, an earthquake that cut a bunch of cables, or every once in a while you'll get a ship in an area where it'll drag its anchor and cut cables, unless you get a lot of physical damage to the infrastructure, people pretty much don't even know it's there. It just sits in the background and works. It's just like air, right? It's just, we got it, we breathe it, everything's good. Same thing with the network. And honestly, it should be that way. Right? We strive, the whole industry works hard. Ciena in particular has been, very good at providing what we would call mission critical or high availability designs on all this stuff. So, if there is a failure, it'll automatically find another path through the network and such. So it's, it's designed to work really, really well and just sit in the background and you don't even know about it.
So I'm a super curious person, so I want to dive a little bit deeper on this because
diving in submarine is a good thing, right? You got that. All right.
That's why I make the big bucks.
There you go, dude. That's good.
So I want to understand like the landscape of the internet. So let's say we got Sienna and they have one of those cables. It's like a thicker than a garden hose, right? And do they have multiple ones of those stretching on the ocean floor?
So actually inside the cable, you'd have, 4, 8, now 16, people are even looking at 32, pairs of fibers that will run in parallel inside of this one cable. And then each one of them carries, information across. And
then will you have like multiple of the big ones, or you just have like one big one?
So it goes with demand, right? So early on between, any two land masses, one cable. Then as population, gets more and more on board with the internet. So transatlantic grew the first, transpacific grew next. But, if you go back and you look at all the different cables that have been deployed over time, it follows the deployment in some sense of the internet. And, the internet kind of scales with eyeballs, right? So you can imagine as China, India, Southeast Asia, as all those countries became more and more internet centric, the connectivity patterns changed and more cables were put down. So, you can get maps, you can go online and look at some of the maps of the submarine cables, and you'll, like you said earlier, you'll see this whole web of interconnections, and you'll then see, okay, now I see how the world really does, communicate.
Okay, so then help me understand, like, let's take just a single garden hose size cable, and it's got several inside of it, and then it's connecting to where, like, what are the buildings that they connect into? Like you have two land masses, right?
Yep. So years ago, what they would have done is they'd actually have buildings that were very close to the beaches, right? So you'd have a cable landing site, let's say in New Jersey, New York. You'd have a similar one over in the UK or France, right? And you'd have a building there, and that would have all the electronics and the other equipment that would, basically energize the cable and set up all the connections, the photonic flows, the optical circuits and such. What actually one of the things Ciena has been able to do is by introducing a new technology we call coherent communications, coherent detection, we can actually extend that into the local data centers. And so what you really are doing now is you're connecting massive data centers together. So if you've got a big data center outside of New York or outside of Washington, D.C. on the East Coast, outside of Miami, maybe, there'll be a number of them up and down the coast, you can directly connect those to other data centers located, let's say, in Europe, South America, Africa, whatever you need in terms of your topology. And the same would be true going, from the West Coast, let's say San Francisco, LA, over to Hawaii, or directly over to Japan, over to, down to Australia, New Zealand. All those are interconnected on these kinds of cables.
Okay, I'm good. The cable landing site, that's an important thing. Now, I guess I want to form a better question. Let's, I need some background information before I form the question I want to form. Okay. I'm getting excited here. This is a lot of fun.
This is cool stuff. No, like I say, it's, it's a wonderful technology. Again, it's something that a lot of people kind of know is there, but don't really know about it because it does work so well. It just sits in the background and creates all this capacity.
Okay, so here we go. We're going to educate me, and you can boil it down to like I'm a 3-year-old if you want. So the first question I have is what is actually like, how do you refer to the packet of data? Is that like a photon going through light? Is it an electron? Like, how do you refer to, like, let's say we're on a call right now and let's pretend we're
Yeah.
on two different land masses. Let's pretend you're in the UK and I'm in the US.
Yeah.
And data is, entering in through the camera, hitting the camera lens, getting turned into data, going out through, my router, my ISP, and then what happens after it. Like, I'm very familiar with the modem that's in the
Sure.
office, but then what happens when it hits that modem and then goes off into the internet? How does it get to you?
So why don't we start with, you'll be, just for today, because I really don't know where you are. I'm on the East Coast and you're in Europe, just to make it up, right?
Okay, I'll be in Europe.
And we got a video link and an audio link going, right? So you're basically creating, you're taking information off your screen, you're taking your voice, you're digitizing it, right? You're forming packets. Those packets are then ultimately given an IP address, right? So it's typically starting as Ethernet, they'd be encapsulated with IP, and off they would flow into the grand internet, right? With an address that says, you want to talk to me, right? Now, in reality with Zoom, what you're doing is you're talking to Zoom. Zoom's making the connection in the background, and then Zoom's finding me. So we're not directly connected in that sense, but it basically works the same way. So you're generating packets with addresses that get routed to me, right? So they start as an electrical signal. Someplace within the network, they will be turned into an optical signal. So you'll do an optical electrical conversion, right? You'll take the electrons coming in, you'll use it to modulate light. That modulation on the light is that information that you want to convey. That would then go down into this, in the case of this long transatlantic cable, gets dropped in, let's say, in just outside of New Jersey, transits across the Atlantic, comes out, let's say, on the UK, and goes back into an electrical signal, and it finds its way to you, and vice versa, right? So same thing happens for me. My image, my voice, digitized, put into packets, given an IP address that finds its way to you.
Brilliant. Yes, you just made me smarter. Thank you.
Sure.
That's, I'm a big nerd. I was curious to how like electricity turned into pixels. And so I spent like a year hunting down every step. Yeah. I learned about transistors and, how does it come from the power station and step down through the transformers and then go into the computer and go through and then become data. And so I hunted all of that down, but I never did that variation with how data flows across the world. I just knew it was like a beam of light.
Yeah. Well, I mean, that's most people's experience is, either the wireless device, in which case you've got a radio frequency that's been modulated, and that's how you're getting connected to a tower or a Wi-Fi access point, or it's a physical Ethernet cable. And again, it's electrons at that point, right? That RJ45, which is the same everywhere in the world. That's what most people's experience is. But the reality is, generally, as soon as it gets inside of the network to the local central office, in some cases, if you're in an office building, maybe down in the basement or even a local wiring closet, you're going to convert it into light. You're going to do this optical, electrical, optical conversion right there, because the losses on fiber are very, very low, right? So you don't spend a lot of energy once you get the things into an optical format, and they're also very high capacity. So, when you think about, data rates, for example, right? So most people probably are okay with saying a gigabit, right? That's probably about the fastest you typically experience. Most people for, a Cat 5, 6 wire in your house, that sort of thing, you might say, I got gigabit Ethernet. By the time you get into the optical domain, and this is actually one of the changes that Ciena has driven over the last 25 years, is we first introduced a technology called Wavelength division multiplexing, where you put multiple colors of light on the same fiber, and then you run all those parallel colors through one amplifier. Right? So that's dense wavelength division multiplexing. And we also, I know we did that, by the way, about 1995. So that's, very old technology, very well established now. Around 2010, we also introduced this coherent detection model, where you actually use a laser at the receiver to measure the incoming laser, right? And lasers being very precise, you get a lot of information out of it that way. And so when you look at the rates on the optical lines, remember you got this gigabit electrical in your hand is pretty typical. By the time you get to optical rates, you're talking, 100 gigabits, 200 gigabits, 400 gigabits. The stuff that we're now shipping is 800 gigabits, right? And that's per wavelength. Then you multiply by how many wavelengths it can generate. And so, a single optical fiber today, in general, you can think about 20 to 30 terabits on that individual fiber, right? I mean, that's just a tremendous amount of capacity. And it's been that deployment of all this capacity and connectivity over the last, decade or so that's really put the kind of the connectivity platform in place. That's why we can do the things we're doing right now. If you can imagine what the world would be like if we were trying to do this kind of connectivity, this kind of communications on a dial-up service, right? If you go back to the beginnings of the internet, it'd be game over, right? You have to have this kind of capacity and connectivity built right into the infrastructure to make all this work the way we want. So, I think the whole industry is, fortunate, the technologies that we pioneered got widely adopted, widely deployed. And so we've been able to push huge amounts of capacity out there. And that's what, the digital economies are really, thriving with right now.
Is our infrastructure keeping up with demand?
In a lot of places, yes, although there's still, I think you still have issues. Digital divide is a real issue.
I haven't heard this word before. You called it what? The digital
divide? Yeah. I mean,
what is that?
It's the have and the have-nots for good internet access, right? If you postulate that, a lot of people are going to be doing work from home, learn from home, telehealth, you better have good connectivity for that. So if you're in a rural area, if you're in an underserved area, if you don't have good connectivity, all of a sudden now, well, okay, how do I telework? How do I telelearn? How do I telehealth, right? I don't have that connectivity anymore. So, one way to think about it is if you say, historically, how did commerce occur? Well, you go way back, it was, you needed a waterway. Okay, then we could build railroads. Well, then we built roads. And the digital economies rely on the internet. Well, those are the roads now, right? And if you don't have a good roadway, right to your house, or where you're working or getting educated, or where you need healthcare, how do you get it, right? So that difference between who has it and who's not is kind of considered or called the digital divide.
Yeah, you know what? Now that you're describing it, I hadn't heard that term before, so I'm glad I learned that. But I did read a while back that I think Starlink, one of Elon Musk's projects, they actually got some government funding through a project that was to help enable access to rural areas.
Oh yeah, well, there's lots of folks. Many of the big web scale folks, the hyper giants, the Facebooks and the Googles have all had initiatives around how do we improve, broadband access. It's just it's a fact of, the cities are generally better served. There are some good rural areas, but there isn't this, universal access to really good broadband available to people. And you get outside of, the major developed countries and it gets dramatically worse, right? There's still people who, really don't have any access to the internet, right?
How does demand, like, how do you see, I'm trying to build a picture in my head for Ciena, and because you build this infrastructure, and so you monitor, I guess, capacity, how much of total available capacity versus used, and then you add more capacity and make improvements there as demand rises, and it seems to all be in line. We're like, do we have significantly more capacity today than we need right now, or are we like always riding on the edge?
Well, I wouldn't say we're always riding on the edge. We have, in a lot of places it's kind of adequate, right? Because like I say, these digital economies are doing okay, right? But in general, I think, humankind learns how to exhaust, connectivity capacity, just as much as we learn how to exhaust, storage space, right? We take pictures, we store them away. When was the last time you went on your hard drive and really culled out all the old stuff? You probably don't. What you do is you buy a bigger hard drive and make a folder called old stuff, and you take all that stuff and you go in here, and then you got more space, right? So I think we just have learned how to consume, connectivity capacity, computational assets, storage, all that, very, very well. And I think, some of the learnings that are going to come out of COVID, we talked about the work from home, the e-learning, the e-healthcare, all those things. There's gaps in all those. We know every one of those kind of market applications could be better, in some cases much better than what we're experiencing right now. And I think a lot of that is going to drive additional demands for capacity and connectivity. I mean, a good example is collaboration environments, right? They're not, what you really would like is something that's fully immersive. It's if you remember the old holodeck kind of model, if you were a Star Trek fan or something, where you can have a virtual world that you walk into and you can interact with. That's a much different experience than what we're doing. I mean, we're basically, looking at a little flat panel, here's a face and we can talk back and forth, but it's really not good for collaboration. You don't get the same feeling as if you were in a conference room with a whiteboard, right? A lot of times, especially early in a company's life, a lot of the innovation and creativity is, you almost lock yourselves in the conference room and bring in pizza and, we're going to go solve this problem, folks, right? Recreating that again, but in a distributed environment, we don't really have the tools for that yet. I'd say same thing on the distance learning, right? What I've seen a lot of parents have to do is become the teacher, right? You don't have the teacher that walks through the classroom and says, okay, Steve, pay attention, right? The parent has to do that. So are there other things that we could be doing in terms of the distributed school environment that would be better than what we currently have, which is, again, it's kind of a replica of what you and I are doing right now. Telehealth, right? The ability to remotely sense, it's kind of, you go for the dermatologist, like take a picture of what you're worried about and send it to me, right? Are there things that we could do in terms of the resolution, multispectral? Are there other things that we should be thinking about or looking about in terms of the ability to have remote sensing that would be of interest to the physician, right? Those are all areas that I think are going to be ripe for innovation. And I think in a lot of cases, they're going to drive additional demands on connectivity and capacity.
Have you seen any like futuristic 3D holodeck type conferencing stuff?
I've seen lots of proposals, right? I haven't seen one where I said, wow, this is the answer. Well, usually what I see are bigger versions of what we have now in higher resolution, which is all important, absolutely. But I haven't yet seen the real experience. It might be out there, and I might not just know about it, but I just haven't seen it yet.
I'm excited for the future. Someone's going to crack it. I saw you had some articles that you've written, and I read through them. And one of the references was to like volumetric video, which I thought was really cool. That was just unbelievable. It was basically like the one scene from The Matrix, but all the video is like that. Yeah.
Oh yeah. I mean, but that is the kind of experience and interaction that you really want to have. Is it can't just be the flat panel. It can't be what we're doing right now. It's got to be better than that if you really want to kind of transcend distance the way we want. And there's a lot of visual, kind of cues that people get from being in the room together that get lost in this, typical classical video conferencing environment. So bringing some of those back, so I have seen some, what I think are interesting ideas of kind of the virtual meeting room where, you walk up and it's kind of a reflection of a room in a different location, a different building. That looks like an interesting way to go. You still got to get people to come and sit down and chat with you and all that, of course. But so there are lots of good ideas out there.
Yeah, it'll be interesting to see because it's like either the headsets would have to get smaller and be more of like glasses that you wear that are very light and not a big deal, or it would have to be designed in a way that didn't need you to wear anything on your eyes. And then we would have, our offices would still be our offices. There would be some different technology in there and the interaction might be very different. Yeah.
And that's much more along the lines of the old holodeck ideas, right? Where you go into something and it creates that environment for you. It's not something you put on and you wear. But you're right. If it's this big clunky, got a, huge 10-pound helmet you got to put on, you're probably not going to be that effective, right?
And until Musk gets his Neuralink going, then we can just build an app on that. So how did you get into all of this?
Oh, geez. I was probably, your typical nerd, I guess, from as early as I can remember. I was always interested in, science, physics, electricity, electronics. My dad had been in the Signal Corps in World War II. He had brought home a surplus, what's called a BC-348Q, which is a receiver that was in one of the, I think it was in a B-17. It was tubes, vacuum tubes, real old vacuum tubes. So those were actually the first electronic devices I ever used, were vacuum tubes. And my first thing I ever built was a way to power that particular radio, because it was designed to be used in an aircraft, which is a different powering arrangement than, plugging it into the wall. So, figured out how to do that. That kind of launched me into a specific direction of, electronics and communications. Got hooked into the local ham radio, shortwave listening guys, helped them. I always like to build stuff. So I was kind of just into communications. The fact that, you could, with the right knowledge, take, these little devices and all of a sudden make your voice show up, across the room with no visible means of interconnection, I always thought was just really, really cool. And then, I think I was probably 12 or 13, and one of the local school teachers had what's called a helium neon laser, which was not a little thing. It's a pretty good size one. But it would, well, first of all, if you put a beam of light that you can't see, but the dot goes on the wall, which is, again, kind of intriguing. But then you could modulate it and, again, put your voice on it across the way. And I thought, oh, that's really, really, really interesting. So I got very interested in the combination of electronics, microwave, radio technology, and optical technology. And that's effectively what I, spent my time in school on. From there, I went up to MIT Lincoln Laboratory. They had a group that was just starting out in almost the same field, but focused on optical communications, initially between satellites, although later on it was between satellite to ground, and also ground networks. And that, I spent 12 years there, and that was more almost a pure research environment. But about 1994, realized that some of the technology that we had been using in the research labs and building up some prototypes, there was a DARPA-funded project called the All Optical Network that we had built, and I was in charge of building up a test bed. That I thought would be ideal at that point for commercialization. And by happy circumstance, right around when I was thinking, hey, this would be kind of cool to go commercialize, there was a company starting up in the Maryland area that was going to try to build WDM equipment for initially cable operators, but that was quickly changed over to be for what were then the internet exchange carriers. And our first customer ended up being Sprint, right? And way back then, Sprint had just done the pin drop, which was a very popular commercial, right? It was first digital, all fiber optic network, border to border, coast to coast. You could hear, so quite you could hear pin drop. And that produced a lot of interest in their network. They built SprintLink, which was one of the first internet service providers. And so they had lots of capacity coming on board. So they were looking for capacity solutions. Sienna showed up with, hey, we got this thing called dense wavelength division multiplexing, where we can multiply the capacity of that fiber by 16 times. Isn't that cool? And they were like, not only is it cool, it's like, we need it now. And that's literally what launched the company.
That's amazing. And so you have over 25 patents. That's pretty exciting.
Probably right now. Yeah. I don't track them, but yes, there's probably some number like that. Yes.
I think that's what was in your notes or your bio.
Yeah,
by the way, your PR team is really good. I get, notes sent over all the time, and they were like short, succinct questions. And I told our production manager, I said, hey, screenshot this and send it to people in the future as like a good example of good PR
cool.
Notes.
Yep. Yeah, no, they are good.
So
I agree with that.
What is, I'm curious to know, like, what is the patent that you find most interesting or that you're most proud of?
Well, there's probably a couple. There's a couple ones that went into the original Sienna product. One was on, I think it was called uniform gain optical amplifiers. So the way that this whole technology kind of emerged is around, around 89, out of the universities came erbium doped fiber amplifiers, EDFAs. So basically, it's doped glass. If you illuminate it at a certain wavelength, you'll provide gain at another wavelength, and that's how we build these amplifiers. What hadn't been done at that point was applying them into a WDM environment where you had multiple channels. And so I figured out a way to basically offset the slopes of different types of amplifier designs and get a uniform amplifier out of it in a very straightforward way. So it was something that a small startup could do. We provided what at the time was extremely good quality amplification, very low noise, broadband for the time. And that probably enabled, as much as anything else we did, the kind of systems that we built. So you take that one, you combine it with a couple of others that were more around the mapping of information on and off of the optical signals that we were creating. Some of the higher level system patents, I think those are the ones that, looking back, probably had the biggest influence.
Does Sienna have a podcast? Or do you have a podcast?
We do. I do them with other folks, and Sienna does, a fair number of them, often in collaboration with customers or other folks in the industry and such. So, like I say, like you identified it, our PR folks will get you hooked up with anything you need to know about the technology. We do have a whole series of what are called kind of chalk talks, where we'll go through the different pieces of it and give it, in a way that, people can understand it, right? Because this whole business is just a huge number of acronyms, and you really need to translate those acronyms into something people can understand.
I think you should have one. I think you should make one.
Cool. I'll let them know.
Yeah, that's my suggestion. I've talked with, and by the way, if you do it right, we'll help you launch it too. You can come on the show. Okay. We did that with 3 Pillar. They're amazing company, engineering firm. They're actually out up your way on the East Coast, but Jessica over there at 3 Pillars, we actually ran into her at a wedding. This girl walked up to me. Yeah, I had interviewed her, and then like 6 months later, my wife had a good friend from elementary school, and so we're at her wedding, right? Old friend. And this girl walks up to me. She goes, "Hey, are you Joel?" And I'm like, "Yeah." She's like, "Oh, I'm Jessica. You interviewed me like 6 months ago." I was like, "No so cool. way." Yeah. And then they had just started, they had started a company podcast for 3 Pillar. And I was like, "Come on." And so we did a special episode where we introduced it. And then at the end of that episode, I think it was like 160 something, 164. I think Jake, if that's right, let me know. But we did an episode with them and helped them launch their new podcast. Oh, yeah. So if you do it, let me know, and you can come on here and we can help you, because I think it'd be cool. I'd also recommend you for Kevin Scott, who's the CTO of Microsoft, the whole organization. And he has a cool podcast where he talks to people that have made, meaningful contributions to technology, usually older technology, and with all your
more
patents,
mature.
Yeah, more mature. But no, that's I was like, it's a really good podcast if you look up Kevin Scott in the podcast store. But
okay, will do.
But mostly you just do these. You just go and do other people's podcasts, hang out.
Well, so we'll chat. We did one, you kind of e-gaming, right? Because one of the biggest kind of transitions that's going on, right? So we kind of talked about faster, right? So Joel, if you came to me and said, "Hey, dude, what's going to happen in the network over the next, 5 to 10 years?" What I would tell you is it's going to get faster, So we're at 400, 800 today. It'll go faster, no doubt, right? So that whole thing will just get faster, and we'll push it right out to the edge. We didn't get to talk about it so much, but when I referenced, what we did back in the middle 90s, 40 gig, we talked about 1 gig in your hand. So 40 gig was a whole bay's worth of stuff, right? So you're talking, 7, 8 feet high, 23 inches wide, lots of stuff to do that. Middle to the end of next year, middle 2021, we're going to be put 400 gig. The module that we can make for 400 gig is going to fit in the palm of your hand, right? So that's just a huge improvement if you think about it, right? So, that means that this technology can go in a lot more places. It can come much closer to the edge of the network than it's ever come before. You can even see a day where that kind of technology makes it into, the tall, shiny building or the shopping center, the local central office, all those things, right? So everything gets faster. The gaming guys sure want faster, but the other thing they want is they want closer latency. From the time when I press a button to something happens, they want that to be as short as possible. And if you're really getting into this, augmented reality, virtual reality thing, there's this thing they call motion photons, right? Which is when you move, things should move with you, right? If you look down, if you're wearing a VR headset, AR headset, you look down, if you don't see your feet, first time you do it, it's weird. 100th time you do it, you start to feel ill, So there's real limitations on this latency effect. And what that translates into is you got to really pay attention to the architecture of the metropolitan networks. And in fact, you're going to start pulling some of this cloud computational capability, which lives in these big, massive, hypergiant data centers. You're going to start pulling them closer and closer to you. Right now, that doesn't mean it's going to be right up the street, but it means that there's going to be some kind of computational resources, just say between 100 and 150 kilometers away from you, to start to meet these latency requirements that you're going to have if you want, really good interactive things, right? So, we did one on that. There's another one, another trend. So you got the faster trend, you got the closer trend. The other trend that's out there is just plain smarter. We touched on it a little bit earlier, Joel, when you talked about Zoom. Smarter is all about how you take this massively complex thing that's getting built, but you make it simple enough that people can really use it, right? And I'll give you the best example of what I think is occurred in the industry. If you go back historically, you probably remember the feature phone, right? Flip it up, open it up, whatever. And it came with a manual about this thick, right? And we would go page through that thing, and maybe in about 15 minutes, you and I could figure out how to put each other on speed dial, Today, you've got a smartphone. The thing is, probably 10,000 times more complicated. You can hand it to a 5-year-old and they're going to figure this thing out, right? And the thing that made that, exactly, yeah. Right? You can give it to them and they'll figure it out, right? And the whole reason that happened is because, the folks who created that technology were so good at the software, the human interface, right? They used the software and the intelligence to mitigate all that complexity. And the premise that we've got, I certainly hold this to be true, is you got to do the same thing with the network. Now, the network should be just as easy to use. It shouldn't require all the complexity that's even there today, because it's going to get bigger, it's going to get faster, it's going to get closer. So it's inherently going to be more complicated, but we better be applying, software intelligence to it to make it simple enough that everybody can use it for what they want. So when I talk about what's going on in the network, I try to break it down into, faster for sure, everything's coming closer, but boy, it's going to get smarter also. So those are the big 3 buckets that we typically been talking about.
That device you mentioned, that it was like 400
gig, yeah.
400 gig fit in your hand. Can you explain to me, dumb it down a lot for me? So what is that device? And you said that if it were closer, it would help me. Can you explain that more?
Well, so it's the device that, if you think back to this electrical to optical electrical conversion we keep talking about, that's the device that does that, right? And it does it in that kind of capacity of 400 gig. You go back 25 years ago, 40 gig took 16 different modules that were about the size of a good sized book, an older encyclopedia book, right? Would be a reasonable size for those things. And on that, you would have gotten 2.5 gigabits, maybe 10 gigabits, right? 400 gig in the palm of your hand, right? And the reasons for that, it's the things that allow us to have, smartphones and everything else. It's the continued progression of silicon, right? We can now do, 7 nanometer silicon, that's the feature size on the actual silicon die. You're going to have 5 nanometer coming next. We can build a lot of our photonic components that used to be, lovingly crafted out of little lenses and such, into silicon as well, into silicon waveguides. We can make taps, we can make photodetectors, we can make modulators, we can make lots of things in silicon. And so we're benefiting from the continued development and evolution of silicon processing.
So a lot of this evolution we're talking about is taking place at the point of conversion.
An awful lot. Well, so that point of conversion from electrical to optical is so critical, because you've got to when you're building out a good infrastructure, you want a lot of capacity, a lot of connectivity. You want to pay a lot of attention to that photonic layer, right? You want that to be really, really robust, because that's what's really creating all the capacity everything else is going to consume. So you pay a lot of attention to that, and you'd like to get optical as soon as you can, so you can take advantage of that kind of capacities.
So why don't I have optical into my office? Why isn't my modem optical? Like,
Well,
why isn't
up until now, it's been cost complexity, right? And you'll give you an interesting story. So one of the things that one of my summer projects, so we live here in Annapolis, but we have another house over on the Eastern Shore of Maryland, and it's 4 owners share, well, it's basically a working farm. So it's nice to be able to, you go from, what I currently do as a day is knowledge work. You get over there and you're doing physical work, right? So you're going to go cut a field, you're going to go plant, you're going to do something completely different than knowledge work. But I've got a neighbor there, and he's in the IT space. Because of all the COVID stuff, he took his family, they sheltered in place over there. Terrible connectivity, just awful. We're 15 kilofeet from the remote terminal. You're talking a couple of 100 kilobits of DSL. That's pretty much all you're going to get. There's some satellite alternatives. I mean, we're talking about the digital divide, right here, right across the bay here. We got together with them by just a fortuitous, the local electric company had to replace some underground lines, got a hold of the contractor that was doing that work, said, hey, could you pull in conduit for us that we could then go to the local cable guys and get real internet service down this road? Because we're 4 houses about a mile off the main road there, and it's a gravel road, right? Long story short, pulled all this stuff in, got all connected up. When the cable guys came out there, what did they install from the pole down to the houses was fiber. Now, they have to put what are called media adapters at either end of it to do this optical electrical conversion back into something that speaks coax that can talk to a conventional cable modem. But all of a sudden now our little neighborhood over there is ready for the next step, which is going to be ultimately a fiber to the home kind of environment, right? So why did they put fiber in? Well, you don't have to have amplifiers. It's actually easier for them once they get the fiber in because they don't have to have remote power and all the other things that go with it. So it is coming, it's just slow, because anything that takes time out in the infrastructure, if you're digging trenches, if you're hanging cable, if you're climbing poles, I mean, that's people and hours and equipment and time, and it just doesn't happen overnight. So it is getting better. An awful lot of the cell towers now are fiber. You have fiber right to the cell tower. If you're in an environment where you can get things like a Fios or, gigabit cable, any of the high-speed connections, those all are based on having fiber closer and closer to the end user.
Okay, so I have Fios, right? So
yeah.
At the office here. So when it's in that big fiber optic box, so that's when it's converting to an optical signal.
So you'll see a cable come in the bottom, which is the fiber, and what's feeding into that is going to be probably Cat 5 or 6, depending upon when the cabling was put in.
Okay, so then help me understand with this Fios concept. If it's optical from like the time it exits my building,
yep.
Does it stay optical? Like let's say it's going through one of your data centers, does yours recognize the incoming optical and then just pass it along like throughput?
No, in general, because just because of the details of how Fios works, where it's basically what's called a passive optical network and the exact technology that's used there. What it'll do is be optical to the first central office. They'll convert it back into electrical. Look at all the addressing, look at the format of what you're doing, making sure where does it need to go. Drop it back down into the, they'll do it effectively as the routing function or the aggregation function. They'll combine you with your neighbors and all that stuff, put it into, basically a format that the internet can then recognize, drop it back into the internet, which will then route the individual packets to wherever they need to go, right? Because what you're doing right now, or what we're doing, sure, it has to go to a certain location called Zoom, but you're also probably, I'm going to guess, you probably have email open. You may have a couple of apps open. There's other things that are going on your desktop right now. They're going to all other places than just Zoom, right? So you can't really have an optical connection dedicated to you and me. What you do is you build that optical connection, aggregate all that traffic onto it, carry it very efficiently to the central office, let the central office process it all and send it to where it needs to go. Some of it's going to go to Zoom, some of it might be going to Microsoft, some of it to Facebook, some of it to Apple, and it spreads it out to where it needs to go on the internet.
Interesting. So it hits the central office. and then it gets sent out to where it needs to go. I got it. Okay. I'm learning a lot in this
Cool. That's good.
conversation. You're very good at explaining. See, that's the benefits of like, getting to meet with all these experts, is the experts can explain it in the most simple way.
That's yeah. Well, it's funny. One of the things, I have a standing joke with my boss, Gary Smith, our CEO, but what does a CTO do here, right? What's the T for? And I tell him it's absolutely technology, but it's also talking, traveling, troublemaking, troubleshooting, and the occasional tantrum. Right? So it's just a matter of, what do you need at that time? Now, my travels, used to be, and I like to get out and talk to customers. I tell them that's really how I get my compass set, right? If you're a boater at all, getting the compass set right, forget the GPS, can you navigate just with the compass, right? Now, today, my travels are all virtual, but I can still get around and do all that. But the other ones are just as important. The talking one, a lot of times the job of a CTO is translation, right? You've got to take these things, Joel, I'd walk in and say, look, we're going to use H.265 over QoS-enabled IP over 16 QAM DWDM at 100 gigabaud on SMF. You're like, wow, okay, that sounds cool, but what does that mean? If I tell you, dude, we're going to put a video in front of you that is going to make you feel like you're, center stage at the theater, you get a much better impression, right? So it's making that translation of, this is the experience you're going to have, with the fact that I'm doing it with these 25 acronyms strung together. Well, okay, that's the detail, right? So, but that communications function, that translation function, taking what is kind of a complex esoteric technology, but turning it into, so what's it mean to me is actually part of the job from time to time.
At what point in your career did you realize that you had like an affinity for that you were good at that?
I don't know, realizing you were good at it and actually just doing it, I guess probably you're different. I was probably doing it really early because, I had friends in high school that weren't as much nerds as I was. I mean, I was into the details of how the shortwave radio worked, how the ham radio worked, how you optimize the impedance match to get the highest transmit power, all this sort of thing. But I would say, hey, you want to come over and we'll grab Paul and we'll go talk to some guy in Sweden. Yeah, cool. How do you do that? Well, we got this ham radio thing, or would you like to listen to Radio Moscow? Just something different. So I had an eclectic group of friends that weren't all nerds and really into it, but I could talk to them in terms of, well, here's what I do, and I know how to do all this stuff, but would you like to listen to, something you've never heard before, right? And so I guess I started with that. And then when I was at MIT is a wonderful environment because it is so diverse. And, you're meeting people that are into just all sorts of other things. And, you just get into conversation. Well, what do you do? What are you working on? And you got to be able to express it in multiple languages. And I don't mean, French, English, Japanese. I mean, talk to a biologist, talk to a, person who's working on astrophysics, talk to somebody who's into the media lab, and you're into the physics of propagation on fiber. It's like, how do you make those conversations work? But you learn. And, I think that was honestly one of the reasons I ended up in a CTO position at Sienna is when WDM went in its early days, it was all acronyms. There were, it wasn't something people were used to. There wasn't even places you could get the stuff built. There weren't even manufacturers for it. We had to kind of invent all that stuff. But we had to convert it into value our customers could understand. And I still remember, I think the first time that the sales folks needed somebody to come in and say, Alexander, can you go explain this stuff? I was like, yeah, I can do that. And I did it with a couple of UGraphs and a lot of talking. And they were like, okay, you're going on all of our visits from now on, right? Because the guy understood what you were saying and we were not able to do that before. So you come with us now, right? So that worked out well. But I do think that kind of translation function of, this very detailed, technical language that we speak, what does it really mean is a part of the job. That translation function, I think, is critical.
So how are you preparing like your team or the next generation, maybe the skip level? Like how do you prepare the leaders that are near you for this next like wave?
Well, so it's coaching. right? It's coaching, it's leading by example. It's interesting leadership is an interesting topic. It's written about a lot, it's talked about a lot. It's one of these things that's kind of inherently social because, leadership means you're influencing people to do something, and they don't necessarily do it because you're their boss, right? That's different. That's more authoritarian stuff, right? If you really want to lead, you have to be able to explain it in a way, what does this mean to me? Why should we do this? Why is this important? Hey, that sounds cool. I understand you're excited. Why should I care? Right? You got to be able to have those kind of conversations with folks. And it's to some extent, for some people it comes naturally. For others, it takes a while to learn it. And honestly, some never get it. Right? They may not care that much about it. They're much more into I want to know the details. I want to know every gory detail about this thing, and somebody else will translate it into value for them, right? So, and it's finding the people who want to make that translation function work well, I think is part of the search, if you will, for, the follow-on talent.
And then what's the hardest lesson that you've learned as a leader?
Oh boy, let's see. You learn all sorts of them. I've done this job for, a number of years now. So I guess it would vary depending upon the size of the organization and then where you are. One of the hardest ones I learned early on was, and you learn more, through failure, if you will, right? We failed on a couple of early customer engagements because we just were wildly overextended. And I don't think I appreciated how wildly overextended because I didn't pay enough attention to detail, right? Which is a known problem with me. My skill set is around synthesis, distillation. It's that side of I guess they call it the yellow side of the brain, if you will, if you follow that kind of, blue, green, red, yellow model, right? I tend to be on the yellow side, where green and blue is more have a good project manager, make sure all the Excel spreadsheet, all the cells are filled out with numbers that mean something, that sort of thing. So I always did best, I think, when I had a really good, VP of engineering, project manager. I would not make a good VP of engineering, for that reason. It's just it's a kind of separation of what you got to do. Early on, when you're a very small company, everybody does multiple jobs. The hardest one for me was the detail around making sure everything was done correctly on the engineering side. So I would, naturally gravitate to get help from people who were really good at that. And I had a couple of folks who kind of explained it to me as, Steve, it's really simple. We use critical path method here, CPM. Just stay off the critical path, you'll be fine. So I was like, okay, I can do that. So, I figured out what that meant, and we worked to move in that direction. But I was always good at taking okay, you guys have got it figured out, and let's go change it, and we're going to go communicate it this way. Right? That was always a skill set that I seemed to do well with.
Nice. I like how, as you talk about yourself, you have a great amount of self-awareness, which is really exciting. Knowing I heard this quote once that I really liked, and it's find out who you are and do it on purpose. Right?
Yeah. No, it's true. It's true. No, if you put me into a VP of engineering role with what, and you absolutely have to have folks who do it. You just do. But I'll give you a real simple way of the spectrum of engineering in this space, right? And it's called hanging a picture, right? You'll find two kinds of engineers that hang a picture. There's ones who they'll get out and they'll measure the wall, and you'll figure out, is it square and is it flat, and everything, right? You'll have all the dimensions and all the rest of it. And there's others that will go, you want it here, hon? Bang, right? And I'm much more on you want it here, hon? Now I can do the other, right? If you have to sometimes, we have these mirrors that we're going to go up in a bathroom, and the tolerances were tiny, and I got out the tape and measure. I can do it, but that just doesn't come as natural to me as, here, you want it? Doesn't that look good? That sort of thing, right? So you have to. That's an interesting way to find your, where you are in the engineering spectrum.
I think I connect with you a lot in that regard because I've been exploring a lot. Like I'm a very self-reflective, always trying to improve type of individual. And so figuring out what I'm best at and then how to double down on that is always interesting, because I can get excited and I can do the
Mhm.
engineering stuff, right? I can do it. But then I was trying to find, because I can do multiple things, right? I was trying to find like which one can I do best and how do I narrow that down? And wouldn't you know, just asking that question and allowing for a lot of time to pass gives
Yeah.
you a pretty good answer, like I'm finding to be true for most things in life. But for me, a couple uh, things that I was using was like, just because I can and it's exciting, would I do that for 16 hours a day? And that kind of gave me asking that question gave me a different perspective. It's like, I can do it, but if I have to choose between these two things that I can get excited about and enjoy doing, there's definitely one I would rather do 16 hours a day.
Yep. Yep. No, I absolutely agree with you. Yeah. I mean, it's good to know you can do it. I mean, I feel good I can do it, right? But would I want to do it continuously? Absolutely not. Right. So what that translates into to me is I value it, right? I value the people who can do it like that. And I don't, think any less of them, that they're not like me. I don't want that, right? I want diversity. I want people who think differently. There's this old saying about, if everybody's thinking the same, no one's thinking. Right. And that's very important on teams, especially when you're back in the ideation phase where you're putting things together, where you're solving an initial problem. You want people from all different, perspectives to look at this thing and throw ideas up there. And some are going to be better than others, absolutely. And, but you got to have that diversity of thought up front. Otherwise, I almost guarantee, and I've seen this multiple times, if everybody's agreeing, it's kind of like, okay, have we really thought through this thing, And so getting diversity in up front and talking it out and, having everybody have their say has been certainly, I've solved more problems, really hard problems that way than any other way.
Do you have any other CTOs or CIOs off the top of your head that would be good for me to talk to, that I would get some people that are similar to you or interesting?
I would actually suggest you talk to our CIO, Craig Williams, because Sienna found itself in a very good spot when everybody had to go remote, right? And he'd come into the company a couple of years earlier, and what he did was, his objectives was to create an environment for mobility, and he wanted to put in place, the kind of cloud-based infrastructure, all the things that you would want for a mobile workforce, assuming that we would still have the very centralized workforces that we did. So it was kind of a hybrid model. But he did such a good job. He and his team did such a good job that we find ourselves in pretty good steads right now for good standing for, this kind of work from home environment, right? So I think he would be an interesting chat about what he put in place, what he saw, why he did what he did, and how it ended up, because we're in a reasonably good spot in terms of being able to facilitate the remote workforce and such. I mean, right from Gary on down, Gary kind of set the agenda around, and these aren't his words, but I would phrase it on, take care of the people, they're going to take care of the company. And Craig had made sure that they had the tools to do it. I would encourage you to have a conversation with Craig.
Great. No, I love referrals and suggestions to people, because that seems to drive the world.
Yeah.
Well, thank you so much for coming on and hanging out.
Hey, no, Joel, this has been fun. I can see why you like doing this stuff. Plus, meeting all those people, all the variety of folks, right? Talk about diversity. You must really enjoy this. It's a good thing. It's one of those things, right? Do what you like, or do what you love. The money will follow. One of those words out there. So that's good. Cool stuff.
Yeah, and it's not a straight line.
That is for certain. No, I understand that. You can't be in telecom and optical and not understand what ups and downs mean.
Oh, this is great. So I'm going to add you on LinkedIn.
That's cool.
And then we'll reconnect, and I'll send an invite out to you next year, reconnect, catch up on what's going on.
Yeah, that'd be great.
And, talk more, because there's lots of topics we didn't get to, but I'm going to store them here in the notes, and we'll get to them next time.
Sounds good, man. Take care of yourself. Stay safe.
Thank you, Steve.